Okay, so when we're looking at these trigonometry modelling sections, so we're looking at our compound angle formulae, where we can develop our double angle formulae, or the triple angles, or using small angle approximations for derivatives, and we're looking at all this stuff. What we really want to fundamentally do is to be able to solve equations, because that's what trigonometry is all about for us. We've been solving these trigonometry equations, or trig equations, such as cosine x equals a half, or sec x is 0.2, or we've been solving equations like that now for a long while. But we now need to think about, well, what if they're not in this form, and they're in the form of a cosine theta plus b sine theta, or something of that form. Now, to do that, we need an equivalent form, which is why this section is currently called equivalent forms. So, what it means is I'm going to pick this one here, because I think it's probably the easiest one to go through. We've got a cosine theta plus b sine theta. Has to be equal to r sine of theta. I'm going to pick plus alpha here. It doesn't really matter, but for the sake of it, I'm going to pick plus. Does it matter? Not really. So let's take this right hand side now. So this r sine theta plus alpha. Now, we know straight away a little formula. So expand this out. Now you are given these formulae. I don't expect you to remember them. I'm going to write these at the side here. We have sine of a plus minus b is sine a cosine b plus minus cosine a sine b. And funnily enough, this is what I'm going to use. I'm going to use this one. It's pretty easy enough to get hold of it with this one. So expanding r sine theta plus alpha, then I'm going to get r lots of just this bit, because don't forget we've still got the r at the front, of sine theta cosine alpha plus cosine theta sine alpha. Then I can multiply through by the r. When I multiply through by the r, I'm going to get r cosine alpha sine theta, just rewriting them, doesn't really matter, plus r sine alpha cosine theta. Yeah. Now the reason why I've done that is because now I can exactly compare coefficients, right? Because I've got an a and a b at front of my cos and my sine, but I've also got these at the front of my cos and my sine here as well. It doesn't matter the order, but what it does mean is I can compare coefficients and say, well, b is the same as r cos alpha, because it's in front of our sine theta here. Then I've got a being equal to, well, the other bit, r sine alpha. Okay? So what we can say is from here that cosine alpha, so the cosine of the alpha that we want, is the same as b divided by r. Just rearrange it. This one, well, I can just get sine alpha on its own. When I get sine alpha on its own, I'm going to get a divided by r. So I know r must therefore be my hypotenuse when I draw my right angle triangle. Put my angle in alpha. Doesn't really matter which your a and b are. I could put them there. In fact, I could just go that and like that. Does it matter? Not really. But also, when we're finding the length, because we need the length in order for our r here in our equation, we know that r squared must be a squared plus b squared, using Pythagoras there. So the r is just the square root of a squared plus b squared, using basic Pythagoras, which is, if you look carefully, the square root of the coefficient of that and the coefficient of that. That's the easiest way to find r, and you always find r first. Now what I'm going to do now is do equation 2 divided by equation 1. When I do that, what's going to happen, you can probably spot it immediately. You're going to get that a divided by b, so a over b, is going to be r sine alpha over r cos alpha. Now, I know a trig identity with tan and sine theta over cos theta. Oh well, that's popped out here. Our r's cancel each other out, and this, well, is just a tan of the angle. which you would expect anyway from here, from the diagram. So therefore, the angle that we want when we fill it in will just be the inverse tan of A divided by B. So, when I rewrite this, I just put my A in there, and I put my R, which I find from pretty easily from those coefficients there, in there, put it equal to each other, and solve the equations as you would, using the change of range if you wanted to. So this is the idea of equivalent forms. Now I'm going to go through another one in the next video, where I'm actually going to do one with some numbers in and not just with letters to showing you the algebra. That's what we'll look at in the next video.